Okay, I'm back after a while with another project. This time it is an object recognition model which is able to be deployed remotely. For example, to be used as a camera surveillance system. It could be used as a car camera safety system or even a start into some self-driving technology project, which I actually plan to continue to develop this project for in the future, but I'll speak about the future of this project later. This web app uses transfer learning with Tensorflow to deploy an object recognition model trained by Google. It's called MobileNet, and it's trained on the COCO 2017 dataset of 90 different objects. I do have to address that similar projects have been done like this in the past, although I didn't use any other code in the spirit of developing my own unique project. They do deserve some recognition for inspiring part of the idea. I did consult their implementation, but honestly, it seemed to me that there were really no guides on the actual code behind the models. And it seemed due to the incredible complexity of those projects. It kind of seemed to me that they were unnecessarily complicated in their implementation. And at the end of the day, the functionality that I was looking for, that I was looking to develop was different. My project focuses on separating the computing and image processing device from the camera visualization device, which means that the main goal is to be able to access the live object recognition stream from the camera remotely. And you can do so either from a laptop with a web server, or you could do so through a mobile app. Since I recently got certified as a React Native developer, I decided to look into what it would really take for me to be able to stream the output of a TensorFlow model into a React Native app. It was actually pretty simple, and I won't get into the details because you can just go into my GitHub repo for if you want to see all the specifics of the code. But I used Expo, which makes it really easy to get an app for development testing. And I implemented a one-screen mobile app, which extracts the local server created by the device doing the image processing. The flow of the project is the following. There's a camera, which is connected to some computing device running the Python scripts. In that case, it would be the Raspberry Pi, or it could be a laptop. And this computing device is in charge of running the TensorFlow object recognition model and extracting the video stream with a library called OpenCV. It's a popular computer vision library with Python. The output from the TensorFlow model is then cast onto a web server, or just a local host, which can be accessed via a specific port from the IP address in which it's being broadcast. And then using a web view with React Native from our mobile app, we can extract the live video with the object recognition layered on top of it. That's about it. The demo you're looking at is from taking it out on the road while I was driving in the daylight. And it was about sunset time, so there's not that great of a light, but it's still pretty good. And the following clip is from driving at night. It's worth noting that in the night clip, the camera moved slightly and got out of focus, but it can still recognize a lot of cars and traffic lights, and even some people walking. There are some problems with this project on the Raspberry Pi as of now, since the model I'm using doesn't seem to run fast enough for a real-time application that would be useful while driving. So some research is going into testing other models to find a fast enough one that will not require anyone to buy an extra USB processor or anything like that. I've seen other projects that require you to use the Coral USB accelerator for the Raspberry Pi. And I just really want to avoid that because it's like $350 or something like that. And I'm not going to drop that kind of cash on a Raspberry Pi project just to get a couple extra frames. And the plans I have for this project in the future are to expand the program to interpret the distance to other cars on the road and to determine the appropriate time, when the appropriate time would be to stop or to accelerate, and to have the model produce sample driving decision outputs based on what the camera is detecting. For example, if it detects a car in close proximity, as well as a stop sign nearby, the model should produce a driving decision output to start slowing down and eventually stop without hitting the car. This would be expanded by equipping my car with a range sensor in the front, or even expanding the project to have an extra camera in the back and having multiple camera inputs. But connecting these new sensor inputs to the Raspberry Pi to make the decision. This would also allow the creation of interesting data sets which further models can learn from, while implementing a sort of continual learning strategy for self-driving technology. I hope this video was entertaining and educational. Feel free to check out my GitHub repo in the description if you want to clone or modify the project. And thank you for watching.